Hey YouTube, Jay Kilroy here, back from my trip to sunny Pensacola, where I had the pleasure of visiting with Adam Booth, A-Bomb79. If you're watching this channel, you should be watching his channel. If you're watching his channel, you should be watching my channel, A-Bomb79, Adam Booth, a great machining channel on YouTube. Anyway, I got to visit with Adam and his buddy Gil, and had a fantastic time. Adam gave me a full tour of Motion Industries there in Pensacola, and what a booming operation they have going on there. Adam, obviously a critical piece of that team, and doing great work. Also got to visit Adam's shop at his house, and it's as nice a shop as anyone could want at their home. Just very neat, very organized. It's very obvious from the way everything is laid out and from the way everything is stored that Adam has been in these shops for his whole life, because it is just right. Everything is right where it needs to be. It obviously, his layout of his shop and his storage and his working space, you just know immediately that you're working with a person that has a lot of experience. They really know what they're doing, because their shop reflects that. Anyway, while I was there, Adam gave me these bushings that he got that didn't fit his overarm. Well, Adam, I'm sorry to say, they don't fit mine either. I'm surprised, but if you look here, this is the total width of the overarm support for my mill. So you're talking, that's 1 3/4 inches, right? Well, these bushings are 4 inches tall, and so they obviously won't clamp up. Everything else is right. The key position's right. So they won't work for me either, buddy. So I think what you and I need to do is we need to find another willing recipient, someone that has a machine that we can make work with these things. So what I'm going to do is I'm going to take some detailed dimensions of these, produce a drawing, and then we can use that to figure out what these actually fit. While I was down there, I also wanted to show folks that might not understand, these are the running bushings that go on the arbors, and they come in a couple different standard sizes, and this is a 2 1/8 bushing, fits here. This is a 2 3/4 bushing that fits here. While I was there, A-Bomb gifted me with another fine item, and this is a A-Bomb approved knocker, and it's you've seen him use these a lot in his videos, and I'm looking forward to getting a lot of use out of this myself. And it's a chunk of lead, let me tell you. Other things that happened recently, Todd Manning, aka the Blue Rag Man, made a visit the other day, and always pleasant to visit with Todd. Unfortunately, wasn't able to visit with his sons. He has 2 young boys that are just fabulous, great to visit with, very smart and engaging young men. And anyway, Todd brought me some blue rags, and you know, rather than try to explain to you what he brought, I'm just going to show you. Okay, there you go. That kind of puts it into perspective. These things rock, right? I used to have a supply of these back when my dad was still in the medical business. My dad's a retired surgeon, These are rags they use in surgery, and they come in like a 5-pack. And when you open them in surgery, they're no longer sterile, so you can't use them. So if you open a pack and use one, you got 4 that you can't use in surgery anymore. And that's how you come apart these rags, and they're fantastic. So, and you can always use around the shop. So Todd, thanks a lot. He even included a little Kilroy was here on the tag, and he and I had a really nice visit. And he's got some exciting news coming up. Maybe we can get Todd to do a couple of videos. He's got some exciting news coming up at his shop, some new machinery acquisitions at his shop. It'll be a lot of fun. So, and last but not least, before we get on to actual work, I got a piece of viewer appreciation mail in the mail. Right here it is, right here. And it's a beautiful Niagara cutter. Look at that. Look at that. Right? And it's new old stock, obviously. It's a 4 by 3/4 by 1 1/4 bore. Here's the problem. I don't know who sent it. So, if you were the individual that graciously and generously donated this to the cause, and you'd like to be known, please speak up. I'd like for you to let me know who you are regardless, just so that I can thank you properly. And if you don't want me putting your name out on the air, that's fine too. I understand that. So now we're going to move on to the project at hand, which is the power feed project. Drag my parts back over. Good news, I got my new bearings in. These are the 7305 ball bearings, thrust ball bearings that go on this portion of the shaft. So now that I have the bearings in, we can start working on the shaft. So let's get some material together, and let's start making some chips. Okay guys and gals, got a piece of stock here. Here's our original part, largest diameter. Largest turn diameter on this part here is 1.269. That'll be the same for our new part. Got a piece of 1 5/8 inch stock here. So we'll have a fair amount of material to take off. But this was already this length, so perfect, right? So I'm going to use this, and we're going to go ahead and get set up in the lathe. We're going to face and center drill both ends, and then our order of work is going to be to start from this end, move down this way. And the reason is because this end here just goes into that little female socket adapter and has a spring pin. So this isn't a super precise fit, and but it is the largest diameter. So once I've got this turned and this shoulder turned here, then I can turn the workpiece around, grip this in the chuck, and then I can do the rest of the features all the way out while supported with a center. Rather than the other way around, if I did it the other way around, I'd end up chucking from one of these smaller diameters here, which is not as strong, or I'd end up chucking from this diameter, which is my bearing fit. So this is the piece that I don't want jaw marks on, and I want my best fit right here. So I don't want to chuck on this side. So we're going to start work and do this end and this shoulder, then turn it around. I got my doors open today because the weather's fantastic, so it's just pardon the noise, people driving by. We're going to start work, chuck, and we're going to do this adapter end first, and then we're going to work our way out here and the changes that we have to make in the piece coming out. involve removing this shoulder right here. So anyway, let's get going. Got a little bit of hangout here, so we're going to take it real easy. Got our face in the center. We're going to turn around and do the other end. Alright, we're center drilled on both ends. Let's get a center back in the tailstock and let's start cutting. Okay, we're going to start off with 1.612, our biggest diameter. What we need on here is 1.269, so I'm going to 0 on that. And then right here it says we're 340 big. So I got plenty to take off, so let's get with it. Alright, we're 50 thousandths big on this side, so what I'm going to do now, before we turn down to that finished diameter, is I'm going to go ahead and swap it, and then we're going to turn the rest of the shaft down to that same number, and that way I can make a cleanup cut and clean up all of this. The other big advantage here is now that I've cut down a little ways, the workpiece will go fully into the lathe bore here. So let's go ahead and get this going. Oh, also wanted to point out that when I left Adam's shop, he gifted me with some cutting lube. Seems he has 55-gallon drum of this stuff, and it's a obsolete Exxon part number, and that's what I've been using this morning, and it has been really fantastic. The lube that I've been using, which was a clear pipe threading type lube, which I've been using for years, I had to kind of stop using because whatever they're shipping now is drying to a hard film, which it's never done in the past. Now it dries to almost like a paint. So hopefully this doesn't do the same thing. So let's go ahead and bring this down to size, and then we'll get the whole piece turned down to one size. Then we'll start looking at our dimensions.
made 3 quick cuts there, 4 cuts or so. We're still about 50 thou larger on this side, so we're just going to go ahead and cut that all. Bring that in one cut. Alright, let's see how close we are here. This side is still 50 thousandths big. And this side is 52 thousandths big, so I got a 2 thou step right there. No big deal. So we're going to go ahead and start work on the adapter end. We're going to slide some more of this up in the chuck here. We're going to go ahead and start working on the adapter end that adapts to the lead screw right here, and then just kind of start working our way back down the shaft. Alright, I got the piece moved back here in the chuck. I went ahead and took a good cleanup cut across the face here, and I've marked off, and we're going to go ahead and make the cut for the diameter for the adapter, and that is basically 25 millimeters, and we got to take off a whole bunch, about 346, 350 thous we've got to take off. So let's get going here. Smoky one right in the chest on that one. Let's see. Right, we got about another 110 to come off of there. And, making some good progress. I'm going to go ahead and make a couple more cuts of 50, and we'll have about 10 thou left for cleanup. Alright, might be in time to change that insert tip around. Now the finish is pretty good. Let's see where we are here. We're about 12 big. I mean, it's time to get out better measuring equipment. See, we are at 90, 75, 90. We're at 90, 97. So, measure the original here. Oh, nice. The original's at around 5 thou. Okay, let's get some measuring tools out and regroup. Alright, so I went and checked. There's a little irregularity in that stub shaft, but I'm not going to worry about it. We're just going to go for a nominal fit. And So I am still about 9 thou big on this diameter right here. So we're going to fire it up and take off about 8, maybe 7. We're going to take off about 8 and then we'll clean up the rest of the size here. Alright, nice smooth finish there. Okay, yeah, it's telling me I got 1 left, which is what I was shooting for. Let me get a file. Alright, we got a file here. We're going to rub off a little. It's a Lathe safe file. It's got a safe edge here on this side. Always use your files with handles. By the way, if Tom Lipton's watching, I got these handles after I saw them on your channel and really liked the look of them. McMaster Car product, by the way. Fantastic. Cheap and very nice product. Let's fire it back up. Alright, we are good to go here. Gonna throw a nice chamfer on that edge before we swap the workpiece around and start to work on the other side. Swap the workpiece around. Now this is the whole end here. Now that I'm pulling it out, now that it's been cut, I'm going to go try it in the in position. Alright, fits like a glove. Can't complain about that. Once again, we're cutting this order because that fit right there, this diameter is really kind of a well, relatively unimportant fit compared to some of the other diameters we have to do here. So that's why we're doing it first, so we can hold it. Now we're going to turn our shoulder. There's a shoulder here, and there's a 25mm diameter here for the 2 bearings, which I did get in. 2 bearings go about here, and then the rest of this all the way out will be turned to a 5/8 diameter to fit the bronze gear from the power feed and the crank handle for manual operation. So the first thing we're going to get about doing is turning this diameter, turning this shoulder diameter right here, which is going to be a distance of, we've got to turn that 0.321 or about 8.15 millimeters. 8.08 millimeters or 0.321. I'm using the standard. So let's, and that's going to just stay at this diameter. So we're going to turn this whole thing down to the bearing fit diameter basically, which is going to be for a 25 millimeter bearing. Alright, we got to take off a whole lot of metal here. We got to take off about 335 thou all the way down this shaft. So I am certainly not going to bore you with that, but we will get going here, and then I'll catch back up with you when I'm getting close. Alright guys and gals, I've made a series of passes here and got us down to about 57 thousandths over size. 24.99 millimeter actually is what it measures out to with the trusty digital Michitoyo mic. So we're looking for 24.99 or basically 25 millimeters right on the money. So let's get with it. We're going to take off about 37 here. A-bomb approved cutting lube. All right, let's get a measurement here. We're 57 off. And we're now 21, so I didn't quite get that 37. I got about 36 off of there. So, and the reason I'm taking the reading, the measurement here, is because this is the only place where it really matters. This is where the bearings actually go. The bearings go right here, right? So, and all this is going to get turned down otherwise. So this is all that really matters right here. So we're 21 over. So we're going to cut that in two and take about 10. Now let me get some pliers and clean this up. Okay, at this end here, I'm showing 1.4. 1.2. 0.2. So we're getting right down to it. All right, I've taken a couple more cuts. I'm showing 0 out here. I'm showing a little bulge in the middle because the workpiece might be getting, you know, a little thin. It's pushing away from the insert. I'm showing 0 here. I'm showing about 1 here. About 2 here in the middle, and I'm showing about 1 here. So there's a little bulge here in the middle. So what I'm going to do is I'm going to take a spring cut right now. I'm going to slow my feed down. I'm going to take a spring cut, and I'm not going to mess with anything else. We're going to slow down to about a 3/1000 speed. About half the speed of what we're cutting there. And we're not going to touch the cross feed. We're just going to let it cut. All right, there we go. A very snug fit. Not quite a press fit, but you got to be honest about these bearings. These replacement bearings, they're not the most expensive bearings in the world, which is a nice way to say they're cheap. And I think I'm gonna have to install them with some preload, in order to get the kind of performance out of them that I'm expecting. So that may be something we have to work on. There were a couple of little shims that were in here behind the bearing retainer, so we're going to probably have to work something out in these. These are back-to-back thrust bearings, right? So they counteract thrust from either side. So we're going to have to get some sort of preload assembly in there to put a little pressure on these to tighten them up, because they're just kind of loose. And they're not, you know, these aren't spindle bearings. Obviously, it won't affect the accuracy of the machine, but I'd like it a little tighter than that. So let's go ahead and mark this off for the bearing race, and then we're going to turn the entirety of the rest of this shaft down to 5/8 of an inch for everything else that goes on it.